Welcome, everybody. Is this going to mic on? Is that picking me up? Okay, excellent. So it's 1:30. He started my timer, so we're going to go ahead and get started. Welcome, is everybody still coming in? My name's Andrew Hall. I'm program manager on the diagnostics team in Visual Studio. What that means is we own the debugger, we own IntelliTrace, which is historical debugging capabilities, profiling tools, and the new Android emulator for Visual Studio 2015, if you've seen that. After I graduated from college, I wrote line of business applications in visualbasic.net for a while. Went back to graduate school. While I was finishing up grad school, had the opportunity to come join the debugger team at Microsoft. So I joined that about 7 years ago, and I've loved it, so I've never left. I've spent my entire time in the diagnostics team. I've done a little bit of traveling around between the debugger, the profiling tools, and the code analysis tools. But I spend most of my day job thinking about debugging tools. So hopefully everybody here is in the right session. Debugger tips and tricks for .NET developers of Microsoft Visual Studio 2015. A lot of what I'm going to show is general debugging tips and tricks. A lot of it's been available in Visual Studio for many, many years. I will certainly call out what's new, and we'll see some cool new stuff. But you can assume that unless otherwise called out, that it probably works in the version of Visual Studio that you're using. Quick survey, how many people here are using Visual Studio 2013? Okay, almost everybody. Excellent. Anybody here not have 2013, have an older version only? Okay, just a couple people. So why are you here? A couple of quotes for you to ponder up on the screen. Turns out that debugging is actually hard. And another quick survey, how many people took a programming class at some point in their life? Okay. How many people took a debugging class at some point in their life? Okay, only a few people, very few people. So the interesting thing about programming is as you're writing code, everybody teaches you how to do that. Nobody teaches you how to debug it. And I remember when I was in school, I could actually tell the people that were going to make it versus the people that weren't, people that could figure out how to find the bugs in their code. Because as we all know, well, most of us write bugs, maybe some people don't. So what are we going to talk about today? I'm going to briefly show you 3 slides of 3 new things that you might be interested to go check out. But the things that I'm not going to have time to either go into completely or have time to cover it all in our talk. We're going to look at 65 minutes of demo, so I promise we will spend a lot of time in Visual Studio. I'm going to tell you how you can help us make Visual Studio better. So there's a call to action at the end of this, and then I'm going to have a slide with some resources that you can go check out. Does that sound like a reasonable agenda? Excellent. So diagnostics tool window. This is something that is new in Visual Studio 2015. Not sure if people have seen it yet or not. We'll look at part of this later in the talk. But it brings in performance tooling, historical information as well into the debugger. It's a window that's going to pop up when you start debugging. And I have a link to the blog post at the bottom, so you can go find out more information about that. The things I do not cover in the talk today, which are going to be the historical components of this, we'll talk about the performance stuff briefly, are going to be covered in a talk on IntelliTrace at the end of the week on Friday. So mark that on your calendars if you're interested in that. UI debugging tools for XAML. Anybody here does WPF development or is doing Windows Store application development using XAML? We've brought in some tools. If you're a web developer, you'll recognize they're very similar to the tools you have available in the browser for figuring out styles. Right? You can click on something, you can click on a UI element. It'll show you how that fits in the live visual tree. You can go inspect the properties. You can even edit the properties on the fly to change your styles, figure it out that way. Last thing, Android support. If you're interested in doing Android development or already doing Android development, Visual Studio ships a really, really fast Android emulator. We've also enabled support for doing C# via Xamarin Partnership, C++ applications, and Cordova applications, which are JavaScript and HTML applications. You can do all of that directly from Visual Studio. So that concludes the sort of intro part of our talk. And we're going to jump straight in, and we're going to look at the product now. Let's go over here to Visual Studio, and I've written a nice little application with a couple buttons written in WPF, although everything I'm showing is going to be applicable across the C# spectrum. Visual Basic spectrum doesn't matter what you're doing. So it's going to go ahead and pop up and launch for me here in a second. Somebody should go ahead and profile this, so it should have already been compiled. And what the application is going to do is it's going to talk to an ASP.NET server in the back end. So I see what I did, build. The danger of demos is you make sure that everything works correctly, and then you fix all of your problems before you actually get to it. So let's go ahead and just restart Visual Studio really quick. I don't know why that's very interesting. So any questions while I'm sorry. Could I debug that? That's a question. Yes, I could. So while we're figuring out what's going on here, let me figure out, I was thinking about on the flight in, we had a little bit of a bumpy flight, so I heard an interesting story I think I can make relate to this. Muhammad Ali, anybody know the great boxer Muhammad Ali? Was on a flight, and it got really, really bumpy, and so they told everybody to put on their seatbelts. And Muhammad Ali didn't put on a seatbelt, everybody else complied. And then, so what happened was the flight attendant said, put on your seatbelt. Muhammad Ali says, Superman don't need no seatbelt. Flight attendant didn't miss a beat. Flight attendant said, Superman don't need no airplane either. So if you happen, I told you I could make it relate, I promised I would. So if you happen to be a developer that doesn't write bugs, I'm not going to be able to help you today. But if you are a developer that has ever had to debug a code, even if you didn't write it, if it happened to pop up in somebody else's code that you inherited, happened to have a bug that way, then I can help you with that. So I don't know what's going on here. So Visual Studio. This is the danger always of showing the fresh bits of nice. So we're looking at the RC build of Visual Studio. This is why it's an RC build of Visual Studio and not directly a RTM product yet. So it comes with a Go Live license, which means you can develop it, use it to develop your applications. You can use it to do things in production, but you won't be able to. We're going to still fix it, we promise. So it'll support build-to-build upgrade. So hopefully this launches for me. Builds, compiles, runs, debugs, because that would be useful. Because it hasn't failed for me yet. So, build succeeded. Excellent. There we go. Come on. I don't know how, I did not make apparently the right sacrifices to the demo gods this morning. I should have rebooted the computer ahead of time. All right, so this is awesome. This is great. Continuing, switch to end task. No way to make me sweat better than this. So let's figure out what's using the CPU. Oh, there we go. So we go ahead and close that. So now there we just debugged it using Task Manager. Found the thing that was using CPU. I killed it. So first tip and trick: Task Manager is a great tool. All right. So now let's do build solution. Worked great. Let's go back. Set my solution to be launch how I want. Set a startup project. Now it will indeed fire up and start running. Wow. All right. So we're going to have something later in the talk that I was going to show that I'm going to turn off because I think that's actually causing my problems here. All right. So we're going to do this. So one of the things I was going to show, has anybody seen the new performance integrated tooling into Visual Studio? No? All right. So continue waiting. I think that's actually what's causing my problem here. So we've done a lot of work on it, but there's a lot more work that needs to be done, obviously, to kind of flesh out all the gremlins. So as I do this, I'm going to go details, dev-env, and task, yes. Standard collector is not running. So when we launch Visual Studio, wow, I'm very sorry, people. This I promise everything worked flawlessly 20 minutes ago. So, all right, so I'm going to come in here, debug options. I'm going to turn off the integrated performance tooling for now because I think that may be causing some of my problems. We'll look at it later if it'll work for us. But so I'm going to fire this up. It'll build my application. Worst case scenario, I'll talk about what I'm going to tell you as I reboot my machine. So, all right, we're gonna do that really quick. We're gonna just do a reboot. So, shutdown -R-T. Wow. All right. So, oh, there we go. All right, app finally came up. Woohoo! All right. So my dad always said you can't let these computers win. So as soon as it saw I was going to reboot it, it gave up and decided to participate. So sorry about that. So my goal here was to have an application that provided you a nice greeting. So I wanted it to say hello, and I'm supposed to pass a conference argument to my application. So obviously I failed to do that. So first tip in debugging is the way to get things like that working is to go into your project properties, so Solution Explorer, right-click on your particular project, and say Properties. And there's a lot of interesting debug things that you can configure. So you can actually change the start project. If you have a DLL and you want it loaded in another application, you can do the start external program. So for example, if you're developing plugins for Office, that's how it works. It'll launch Excel or Outlook or something like that. You can start a browser with URL. Don't know why you want to do that in this case, but it could be interesting in some other cases. I can add my command line argument. So in this one, we'll say we're at Ignite. And so that's going there. And the other options that I have here is I have a thing called, I can change my working directory. I can set it up to use remote debugging. So if I have an application running on a different machine, just from the project properties, if I have the remote debugger running on that machine, I can press start debugging. That'll fire up and that'll start the application and be debugging it on the remote machine for me. If I have any native code, I can enable native code debugging in conjunction with managed code debugging. I can enable SQL Server debugging. So we actually have a T-SQL or SQL CLR debugger. If you're doing any of that, you can debug from Visual Studio into your database as well. And then we have this thing called the Visual Studio hosting process that is a performance improvement. What it does is it spins up and it loads all of your framework references into the process before it even starts. So when you press F5, that way, like, we don't actually have to load all those DLLs. You already have a process created and you already have the framework modules loaded. So that'll speed up debugging. So I provided the conference Ignite flag. So let's start debugging again. And it's going to pop up. And it's still not working quite right. So it's picking up the conference part of the flag. It's not picking up the actual name of the conference, which is Ignite, which is what I wanted. So I'm going to go into my main page where I'm doing this, and I'm going to start debugging it. Unfortunately, I've gone through, and I'm sure nobody's ever done this, but I started adding a bunch of other code at the top of my source file, so I don't exactly know where to go to scroll to find the entry point to my application so I can start debugging it. So I'm going to choose to do a step into or a step over will start debugging. And if you have a feature on called just my code that's going to not stop the debugger in any of the framework code, it's going to actually land me on the actual entry point to my application just when I do step into or step over. And so now I can step through my application and I'm debugging significantly down, about halfway through down this file, without having to scroll, find the right place to set a breakpoint. So as I go, it looks like I'm setting my greeting string here with the string.concatenation, and I'm calling a couple functions. Say I want to know what all of these functions are going to return without having to go manually type them in and evaluate them in one of the debug windows. As you know, as of Visual Studio 2013, when I step over this particular function, I see all the return values of all of the function calls that occurred on that line. So that's new. It appears in the autos window in 2013 and 2015. It also appears in the locals window in 2015. So if you have a preference on which window you prefer, you can get both of them there. Additionally, return values are available through something called a pseudo variable. So it's $return value, and this is an in-index one because I had obviously had a lot of them. So return value will show me the first return value, but if I want to get other ones, so I can do return value 2, for example, and it would show me the return value 2. And so you can do that for as many as there were. If there's only one return value and you had a 2, it just won't evaluate. It'll tell you that that variable doesn't exist. So return values can be incredibly useful for managed debugging whenever you're calling functions like that. So you don't have to sort of find another way to evaluate them. Step, just see everything that was returned as part of that. So it looks like the problem here is if I go back to my autos, I can see that the get conference is returning the conference flag. It's not returning Ignite, so there's a bug in that. So I can change the position of the debugger without having to restart debugging using a feature that we call set next statement. So you can do it via right click, set next statement. The location that's going to execute has been changed by the debugger, so I'm back up in this line of code. But any side effects that occurred as opposed to executing that code previously are still in effect. I haven't undone stuff. I've simply changed what's going to execute. So for example, I moved it up. View model is still initialized, even though I moved it up and told it to execute the line that's going to initialize view model again. So besides right-click, I can simply grab and actually drag this, and it'll come down here. So you don't have to find it in the context menu via right-click. You can grab the little yellow instruction pointer, and you can change your set next statement that way to change what's going to execute. This can be really useful if you're dealing with complex conditional branches, because instead of getting the inputs right to the program to set it up so it parses all those paths, you can simply set next statement and force it to execute a conditional branch that maybe the inputs wouldn't have dictated. So that's one place that's really useful. It's also really useful for going back and re-executing stuff like we just did here, as opposed to needing to go back and restart the application or something like that. So I want to get into this get conference function now, and I don't want to go without navigating to definitions. Anybody know how I can do this with one action in the debugger? So I can right-click, and I can choose a option here that says step into specific, and it's going to give me a line or a list of all the functions that occur on that particular line of code. So if I want to step into the get conference, which is going to be the second function executed in this case, right-click, step into specific, the debugger will execute up to the entry point to that method of get conference. So I'm now inside of my get conference function, and the other stuff's already executed. That can be a useful tip for you when you're dealing with multiple function calls on a line. Rather than going to definition, setting the breakpoint, right-click, step into specific. It's a single one-time breakpoint. You don't have to deal with cleaning up breakpoint or anything like that. So I want to run down here. Remember, we're fixing a bug to try to figure out why it's saying /conference instead of /ignite. And it looks like where I'm assigning the name of the conference that I'm going to return is down here. And I want to run here. And instead of setting a breakpoint, I'm going to right-click, and I'm going to say run to cursor. I can do this with the keyboard, Control F10 as well. And what that does is much like step into specific, it sets a one-time breakpoint and runs to that particular location for me. And so I think I see the bug here. It looks like what I've done is I haven't done an x+1 on the arg. So let's go ahead and fix that. We have a feature in the debugger that allows you to change code while you're in the process of debugging. We call it edit and continue. So I can fix this bug right now, and then when I step over it, I can see that conference has correctly been assigned to be ignite. So application is fixed. It's been patched in memory. But you'll notice this little asterisk up here, meaning that the file is dirty. So after I stop debugging, it's going to have to recompile the binary. That patch has only occurred in memory. We haven't changed the file on disk. Something to note. So now that I'm in this particular function, I want to get back out because I want to keep stepping through. Then we know how I can get back out without going further down without hitting a breakpoint. So I can step into the next function called on that particular line. All right. So I think I may have heard it back, but we have a feature called step out in the debugger. So Shift F11, or I can click it on the toolbar here, and that's going to bring me back out to exactly where the SP get conference function call ended. So now if I do a step into, I'm going to step into the get punctuation function rather than being on the next line of code. So step into can be, or step out can be a really useful thing for getting out of the particular function, but controlling your exact point of reentry. And now another option for getting rolling back to a particular point in execution is you can see I'm 3 functions deep now here. So I have my main window, I'm in get punctuation, get exclamation point. If I want to come back up to main window where I left, run to cursor works in the call stack as well. I can right-click on the call stack. I can say run to cursor, and it's going to run execution back to the point that particular call was made in the call stack. So that can be a really useful feature if you're dealing with deep call stacks and you want to precisely come back up. So these are all productivity tips and tricks for how do you avoid needing to set a breakpoint. I love breakpoints. Breakpoints are very powerful, but how many people here have ever debugged, left one, and then next time you start debugging because you think you fixed the problem, all of a sudden you realize that, oops, I hit the breakpoint, I didn't mean to unset it. Question? If
you do run to cursor in the call stack, is everything still instantiated, or does that really undo it?
So the question was, if you do run to cursor in the call stack, does that undo it, or is everything instantiated? It runs it back. It's a multiple step out to until you get to the point that that particular call originated from. That's correct. It's not undoing. It just does multiple step outs up to the point that you made that call in a call stack. Here's a brief review of stuff that we talked about. I didn't put the demo fail at the beginning. My apology. But any other questions before I move on? It's kind of hard to see. You may have to wave furiously. But all right, excellent. So let's go look at some more parts of the product. All right, so now, once I resume this, we will verify that indeed we have said hello Ignite, as we would expect. So I'm going to take a big risk here. I'm going to stop debugging because I mentioned it needs to be recompiled. So we're going to start debugging and recompiled correctly. So what this application is ultimately going to do, and you're going to help me build this application as we go here today in the talk, is it's going to talk to an ASP.NET web service on the back end. It's going to load some data and visualize it. But first, what I want to do is I want to load the data locally. Data is being loaded from a shared library. So I can do that locally to make sure that that works as I expect before I introduce the extra complexity of web service. And notice that I clicked the button, and I've stopped on this line that says debugger.break. So did you know that you can embed breakpoints in your code with debugger.break? You don't have to manually set them. So if you have some place you know that you always want to stop, debugger.break will do that. But notice that I've wrapped it inside of a debugger.isAttached. Do you know that you can ask the runtime, is a debugger attached? You can change your behavior. So some types of applications actually will turn on extra tracing in the case that a debugger is attached. So you can do that. Anybody know why I did that in this case? What happens if I have a debugger.break and I don't have it wrapped inside debugger.isAttached when I run it without a debugger? It's going to crash the application. So how a breakpoint works under the covers is it's a special type of exception that occurs in your code. And so a debugger.break is compiled directly, an exception that's compiled directly into your code. So without a debugger attached, the operating system sees an exception. It's not handled by anybody, normally in the case of a debugger, and so it's going to crash. So 2 quick tips there. And I do this in my code sometimes when I have odd behaviors that are hard to reproduce. And so sometimes I put is debugger attached, debugger.break, so it'll stop me as I'm testing in other cases under the debugger, and so that I can figure out what's going on, but not wasting a lot of time to try to figure out how to reproduce that at any given point in time. So I mentioned we were loading data. So I have this data provider that I've created here, and when I hover over it, I can see that it's loaded a bunch of data. And notice the first thing is I see this little magnifying glass here. All of this is string data, and what the magnifying glass indicates for these is that there's a visualizer. A visualizer is something that has been built. We have some built into Visual Studio. I'll go through all of those right now, but you can build your own custom visualizers. You can go find custom visualizers for free on the Visual Studio Gallery. But it means that there's a visualizer, at least one available. And when I click the little down arrow here, there's actually 4 visualizers that are built into Visual Studio for strings. We have a plain text visualizer, which does pretty much what you would expect. Just visualize the string. I can choose to wrap it or not wrap it. Choice is up to me. But this is actually JSON data if you look at the format of it. And so I'm going to use the built-in JSON visualizer. This was new to Visual Studio 2013 Update 2. And so now I have a structured view of my JSON. It's searchable, so I can see what all the individual array elements are. I can see that there's a property here, app type desktop. So let me find anything that has desktop in it. So search works. It's very fast, very useful if you deal with JSON data. We also have XML data loaded in here. So there's an XML visualizer. It shows me nicely syntax highlighted and formatted, so it's human readable, even if people didn't put the new lines and stuff like that in there. We have, I'll come back, and then HTML visualizer is our last string. So you can see here that the raw string is a doc type, HTML, et cetera, but when I open the HTML visualizer, I now have a rendered view of that as well. And this is using the Internet Explorer version that's built into your box. So just something to note, depending on the version of Internet Explorer that you're running on, you could actually see slightly different behaviors on different machines with the HTML visualizer. Last 2 visualizers I want to talk about. Anybody here work with data? Is I have a data set loaded in here. So there's a built-in data set visualizer, and there's only one visualizer available for the data set that we ship. But when I ship that, it'll bring it up. Sorry, I could not figure out how to make this bigger. So I'm going to zoom in on it with the magnifying glass, no matter what font setting I changed. But so we have a nice data set visualizer. It visualizes all my data. I can actually even switch between tables. So something to note if you haven't used that before. It can help you figure out what data you have. And finally, I'm going to go down here to the Autos window. This is WPF application, as I mentioned before, and I can see the magnifying glass available from down here. It's available in anywhere you have debugger watches. So available in the windows, available in the data tips as well. And we ship a WPF visualizer as well. The WPF visualizer, when it comes up, it shows me the visual tree, so I can filter down through this. Sorry for the people in the back. I'll try to magnify this again. The bottom left has a rendering of whatever I've selected in the visual tree. And then over here on the right, I have a view of all of the properties for the item that I've selected in the visual tree. So I mentioned we've added new live visual diagnostics tools. So this one only works in a break state. The new tools that we've added only work when the application's running. So they're kind of complementary in that aspect. So, all right. So now that we have that working, looks like our data loaded correctly. So let's run down here inside of this loop where I'm going to go through and I'm going to do a little bit of testing, sanity testing on that variable. So I'm going to, first I want to look at the apps, and I want to make sure that they're what I would expect. And interestingly enough, in this particular case, I can see that the app says app and it has app 0. How I achieved that, normally in other cases, so I would have seen just the item type name. So notice here it says main window for this in WPF. But here, for apps, it shows me something that's more readable. And I accomplished that by adding an attribute called Debugger display. And instead of navigating to that in the traditional go to definition, I'm going to do a feature called peak definition. Has anybody here ever used that in Visual Studio? Okay, some people. So this is a nice way that you can quickly look at stuff in other files, but you remain in your file proper. And so you can see here that I've added this attribute, system.diagnostics.debugger display, and then anything outside of curly braces is interpreted as a literal string. If you look at this app, and then anything inside of curly braces is evaluated as a property by the debugger. So there's a property on this class called app name. So what appears to the user is app : and then that property has been evaluated. So I love debugger display attributes. I sprinkle all of my code with them. It's so much nicer than just looking at a main window, especially when you're dealing with types that are being held in collections. So the question was, how can you go into peak definition? So there's two ways to get into peak definition. I right-clicked, and I chose peak definition here on the context menu. The other option is F12 goes to definition. Alt F12 goes to peak definition.
What I meant is, if you open up the peak definition, the file is being displayed, then you want to go into the method in the file.
So the question is, if you want to go into the file, you are in the file by virtue of having the peak there.
But the window is...
If you want to promote it to be a full document, so you can drag it bigger if you want. That's one option. And then the other option is if I click this, it will actually promote it to an actual document. So if you decide that you're working in the peak, you need to really dig in, you want bigger space, click that little button, it'll go to a full document for you instantly. So now that I have my app list, and we're talking about debugging, I want to go in and really make sure that my properties are what I'd like them to be. So I've gone ahead, I've made an investment. How many people here use data tips? The data tip is where I'm hovering and I'm seeing all this stuff pop up in the editor. They can be kind of finicky, and it can be kind of a pain to sort of, I've drilled down a couple layers, and it's covering all my source code now. So I can press Control, and they go transparent. And that's true for any pop-up in Visual Studio. So when you're typing in the editor, if you get an IntelliSense pop-up in the editor, and you don't want the IntelliSense to go away, but you can't remember what was under it, and that matters, you can press Control, and it'll go away. And it's actually kind of fun to play with. At the end of the day, you're tired, you don't feel that productive, so you just kind of stop and you go like that. Not going to make you more productive, but it's fun to play with. So I can make it transparent with Control. Do you see this little pin icon over here off to the side? So if I do this, it's going to stick it in my editor for me so I can see the property as I continue to step through. So if I go F5, I'm inside a loop, and I can watch that property change. So in this particular case, let's go ahead and pin app. That'll be a little bit smaller and more readable. And so now as I F5 through here, you're going to see that this is changing. So this is a tip for data tips that's really nice inside iterative environments. You have a little mini watch window right stuck in the editor with you. So I could even unpin these windows if I wanted. I could get more editor space back, and I can start littering my stuff with watches. So now if I F11 to step into this, it stays in the context of the editor where I pinned it. So let's go ahead and step back out. And I can even start making comments in there. So we've made it, how many people here have ever opened Notepad and you start making notes about values as you're stepping through stuff? You don't have to open Notepad if you don't want. You can litter it right in here. So I could say app 5, then I run again to the next line, and it's app 6, whatever particular comments are useful for me. And now, when I stop debugging, everybody ever wonder what the value was? You hover over this little pin in the icon, or little icon, and it comes back and it tells you what your value from your last debug session was, including all of your comments. So that's been in there since Visual Studio 2010. So if you have Visual Studio 2010, you can make use of that feature. So let's go ahead and start debugging again. One more thing I want to show with that is when I click Load Data, when I pin it, let's say I'm particularly interested in this. I've liked this sort of optimized view. I want something more global that comes with me. I can unpin it, and it's now going to float. I can put it anywhere I want. I can stick it up here in this wasted space up here. And as I debug, it'll stay. Now, there's only one problem. As I step into stuff, it goes out of scope. So let's say I wanted to watch something that was still in memory, because I know it's on the call stack one method up, but I want to be able to watch it somewhere where I don't have access to that particular variable name. How I can do that is I'm going to go call stack. I'm going to go up here, and we have a feature called make object ID. So in this context, I have my app. Let's go ahead and delete our watches here. So I'm going to type in the variable app, and I have access to that. So I'm going to right-click, and I'm going to say make object ID, and you'll notice there's a little $ that appeared here. So now, up here, or in any other debugger watch window I want, but I'm going to show you can add expressions to these things just like a watch window. If I do $1, that now, as I come back down on the call stack to this other function, I can still see the values of something that I can't actually get by name, but are still in memory. So make object ID is a useful piece of functionality if you need to watch something across different sort of execution scopes, like in this particular case. So,
Can I share this data to my coworker?
What was the question, sir?
Can I share this to other?
Okay. So the question was, can I save my data tips to give it to another coworker?
Sharing.
For,
If I debug my machine, then I can share it to other machines.
yeah, so the question was, can I share data tips with coworkers? The answer is yes. So we have functionality on the debug menu that says export data tips. So you can export any data tips that you've pinned to an XML file that then your coworkers can load. We also, from the breakpoints window, support exporting breakpoints. So if you had a debug session where you found some really interesting information, you can set the breakpoint for them, you can pin the data tip, you can make the comments, you can export those, you can give them to them. They can then import the data tips. So import data tips is right here on the debug menu. And then the breakpoints window is here, and you can import breakpoints from the breakpoints window. So since I did that, notice debug windows. All of our windows in the debugger are under debug windows. They're not under the view menu. So most of you, I'm sure, know that, but it's a good reminder, since even I myself sometimes go look on the view menu out of pure habit. So last thing I wanted to show here is once you start drilling in on things in the watch window, it can get pretty complicated, right? So let's go ahead and step back out here, and let's look at the app. And it can be a couple levels deep, so I can go down here to the owner, and I want to see the owner's email. I can right-click, I can say Add Watch, and so it has now added the property that was really, really buried to the watch window itself. This works from within data tips. This works from within any of the autos or locals windows. So if you're dealing with data structures that are more complex, you get a couple layers deep. You just want to watch that particular property. You don't have to manually type it. Right-click, Add Watch, and I can even, if for some reason I wanted to, add it multiple times. So, yeah. Any questions? Okay, yep. The question was, make object ID only available? No, make object ID is available from any debugger watch window, so a data tip or the watch windows. Yes, question right here.
XML visualizer, can I copy the content from there and paste it into another window?
The question was, can I copy the content from the XML visualizer and paste it in another window? Yes, absolutely. Just click Control-A, Control-C. You have it. You can paste it into another window. So that's true of the XML and the text visualizer. The JSON and the HTML obviously do special formatting, so they don't necessarily support that functionality. So it's a brief review of what we talked about. Any other questions before we move on? Right, I don't see any. Okay, so let's now go in. So I think I have the application pretty much working like I want it now. So let's go ahead and stop debugging. We'll start debugging again. And I've written some tests to validate the data that's coming in. That's going to, how my application is going to talk to the server, but it's going to all run locally now. And when I run my tests, as I said, there's always a danger in these things that when things go wrong, they go wrong. So you're not going to get to see the bug quite yet. I'm sorry. There we go. All right, come back. So we'll start debugging our application again. And now when I run my tests, I'm going to see that I have a test failing. So this is going to be a case where I have iterative stuff. There's multiple instances running through a loop. And I want to go into my code, and I want to ask the debugger to only stop in the case that the value is desktop. I'm not worried about mobile and web because I know that there's not a bug in that case. So I'm going to go into the part of the application that is dealing with this particular code. And I'm going to set a breakpoint. And you notice that when you set the breakpoint now in Visual Studio 2015, I see this little toolbar that pops up here with the settings icon. So I'm going to click that, and that's going to allow me to set conditions on my breakpoint. So I can create a conditional breakpoint. And in this case, I'm interested in the condition being when the value is equal to desktop. Before I do that, however, I'll talk about the other conditions we have available. We have a hit count. So you can do this based on purely the number of times that the breakpoint's hit. So if you want to take a sampling-based approach, maybe a button click, say I want a hit count of 10, so you just click the button as fast as you can, and then the debugger will stop for you the 10th time that you've clicked it. You have a for loop, you know it's failing on the 298th iteration of X. You can use a hit count, or you can use a conditional. Small tip, hit count is a little faster than a conditional breakpoint. So if you know a numerical-based thing inside of like a for loop, you might want to use the hit count if you can do that. Because the debugger can evaluate the hit count at a little bit of a lower level. It doesn't have to evaluate the variable value like it does in the case of conditional expression. And then filter are useful for multi-threading, and we'll talk about this one a little bit later in the talk, but it gives me options that are basically thread and machine and process specific. So if you're debugging code that's running across those different instances, you can choose when to break or when not to break. So I'm going to go ahead and say now my decoded type, and I get IntelliSense in here as I would expect, equals, and we'll say desktop, because that's what's failing. So I'm going to go ahead. It tells me that it's saved, and it's not modal. I can actually copy from the editor if I want. This functionality is available in older versions of Visual Studio. You get to it by right-clicking on the context menu, and you'll see all of the various breakpoint types separated into separate context menus. So you get a modal dialog. We fixed that. We've made it non-modal, and we've combined all the functionality into a single window so that you can find it easily. Now I can close it. I can leave it open. Up to me. I will go ahead and close it here because I have a handy button to do that. And now when I go back here to and click my button to run tests, I can see when I come in that decoded type is desktop. So I didn't stop on the other two ones that I didn't want to stop on. And now I need to figure out what the bug is. So it's expecting to return some applications, but when I run this actual code, I can see that it's actually not returning any applications. So my apps is returning as I step over this, not returning what it expects to return. Let's go back up here. We can run it again because I left my conditional breakpoint. And I'm pretty sure that there's some applications of type desktop in there. So wouldn't it be great if instead of having to drill through this whole list and figure out what's in there, I could actually run a query against it. The good news is, now in Visual Studio 2015, any of the debug windows support Lambda expressions. So I can say debug.applications.where ax.apptype. I even get IntelliSense, .distinct. So let's just call these particular ones. And I guess it helps if I type the right thing. But what's that? Oh, yes. I wanted select, not where. Thank you. That's my problem. Fortunately, instead of having to stop debugging, and I can get my... What? Oh, thank you. It is not my day. I am sorry. Select. There we go. And it executes and runs as I expect. So, and I think that actually, even though I am not capable of typing, apparently, does point out the value of the ability to try this out, because it used to be you'd have to do it, you'd get it wrong, you'd have to stop debugging, you'd have to edit, you'd have to start debugging again. So I figured out the type desktops in there, and this brings me to my next point. But I see that it has a capital D, and in this particular case, desktop's being passed in with a lowercase d. So assuming I want to support that, I now have the ability to fix my lambdas via edit and continue while I'm debugging in Visual Studio 2015 RC. So I want to add the ordinal ignore case. Let's go ahead and step over that. So it's applied, and I can now see that apps, when I enumerate them, it works. I'll press F5. We'll keep going, and I can see that my test passed. Question? The traditional breakpoints, do they work with the conditional breakpoints, do they work with reflected types? So the conditional breakpoint will work with anything that you can evaluate in the watch window as long as it doesn't require native code to run. So assuming that it's all managed code, all based on IL, then yes, that should work. It will simply not work with, if you can't inspect it in the watch window, though, it won't work. So that's kind of the bar for that. Yes?
Does that mean you can have a lambda expression now in your conditional breakpoint?
The question was, does that mean you can have a lambda expression in your conditional breakpoint? Yes. As of RC, you can have a lambda expression in your conditional breakpoint. Same caveat applies. It simply cannot require any native code to run. So things like link to SQL do not work. What we're doing is we actually compile it on the fly, and then we interpret the IL that's generated as a result of that, the interpretation can't handle any native dependencies, right? So it has to be able to completely execute it to completion. Yes? So the question was, have we improved the performance of the conditional breakpoints at all? Unfortunately, we have not in Visual Studio 2015. If you want to come up and talk to me afterwards, I would love to improve the performance. It's something that's on our radar, but it hasn't been completed yet. Yes, question right here.
You said lambda expressions now support edit and continue. What about link statements?
So the question was, lambdas support edit and continue. What about link? Link will support edit and continue as well.
Even link to SQL?
Even link to SQL should support edit and continue. That's correct. Yeah, the limitation is simply that when you're stopped under the debugger to evaluate them in like a conditional breakpoint or the watch window, none of the other threads are running. Whereas if you just edit and continue it, the compiler updates it, we patch the process, and then we actually let it execute. So any thread that wants to, including native threads, can execute. So I've made my edit. I've mentioned before that it's actually, once I've done that, it's not applied. So I'm going to go ahead and click Restart. There's another quick tip. If I want this to be recompiled for whatever reason, I can go ahead and do this. And when I do that, it will recompile. It'll restart my application. So now I think we're ready to go get our applications from the server. So when I click this Get Apps button, it should go out to the server, and it should download them. Unfortunately, I forgot to start my server, which is another process in my application, or another project in my solution. So what I want to do is I actually now want to set both the client application and the server application to start every time I press Start Debugging. So I'm going to go to my solution properties now. And in the solution properties, there's a radio button that says Multiple Startup Projects under the Common Property Startup Project option. And I can set both my WPF application and my ASP.NET Web application to launch Start Debugging every time I start debugging. And if I wanted, for some reason, I just wanted to make sure that the web application was running, but I didn't need to debug it, I can also choose to start without debugging. It's okay in this particular case. We're going to say that we want to start debugging. And now, when I click the Restart button on my toolbar, it's going to restart. And if I go here to the Debug Location toolbar, this is a very useful toolbar. I recommend turning it on. If you choose the General Developer Settings profile, it'll be on for you. Any other ones, you'll have to opt into it on the View toolbars. but I can see, based on the processes that the debugger is attached to, that it's attached to both project_archive.wpf and the isexpress.exe. So I've now validated that isexpress.exe is running. When I hit a breakpoint, you can see on this particular toolbar that it shows you your current thread, and it also shows you your current stack frame. So even though my call stack window is collapsed, by having the debug location toolbar, I have quick access to my stack frame, and I can switch those frames if I want as well. So let's go ahead and continue debugging. Let's click this particular button to say Get Apps, and it should eventually get the apps from the server. So we've correctly started our server. So now, this is the part that I think was giving me trouble, so we'll see if it works for us now or not. But I'm going to click Load, and I want to go fetch only mobile application types. And that wasn't quite as fast as I would have liked it. So I'm going to go Web. Let's try that. It seems to be a little bit slower than just the straight Get Apps functionality, and it's retrieving less data, so that seems odd to me. So what I want to do is I want to go turn on these performance tools in Visual Studio. The performance tools in Visual Studio are on by default, so we're going to hope that this works for us. When I click Start Debugging, they're going to come up, and of course they work now. So I'm going to go to the button click handler that is handling the refresh. So I'm going to go ahead to here. I'm going to find this. If you don't know, this one is right here. Is useful, shows me all the particular functionality in here. So I'm going to go ahead to say load data.click is the particular one I want to go to. And that's not what I want to do. Sorry. The web. So Explorer. Sorry, 1 second. Which load? Come back. Button load. It's load by type.click. Find that. And so now I can set a breakpoint at the beginning of this, and when I click the button, it's going to stop me. I have to get the apps first and then click load. Stop me there. And so I want to now figure out, this is slower than I think it is. I think it should be. So I'm going to set a breakpoint at the end, and I'm going to run the debugger to the end of the method, and I can get a null reference exception. Great. Dropdown is empty. Thank you. Get apps. That does that. Mobile. Now it'll work. Thank you. So let's run to the end. And you see that the debugger shows me at the bottom, in something we're calling a performance tip, how long that code took to execute. That is on by default. It's very subtle and gray. We don't think it bothers people. I turned it off just because I didn't want it to pop up in the demo before this. But it shows me exactly how long my code took to execute. So it's telling me that it took about 777 milliseconds to execute that. Things can, there's warm up and it's web. So let's go ahead and execute this a couple times. And that time took about 642 milliseconds. One more time just for good measure. In the old days, I think I would have had to done a stopwatch and add that in there. So that's just for free by virtue of using the Visual Studio 2015 debugger. And it's taking over 600 milliseconds every time, even though I'm retrieving stuff locally. So I want to now figure out where that time is going in this particular function. So it doesn't have to be between breakpoints. This works just as well if I'm stepping in the debugger. So I can see that stepping from that line to that line took less than 1 millisecond. When I step over this one, that's less than 2. This is going to be an order of magnitude approximation, so if it's anywhere under 5, you can say it was probably really, really cheap. We try to be good, but we're not perfect. And now as I step over this cert, I can see it took a while, and I can see it took about 590 milliseconds to get the server certificate. The interesting thing about that is I should have had the server certificate. I've run this multiple times. So let me go ahead and step into here. And if I go, it looks like I'm doing the right thing. I have a certificate store. But it's not in the certificate store for some reason. And if I look, it turns out I'm actually forgetting to add it to the certificate store. So let's go ahead and fix this using edit and continue as well. So let's say add base URL. And then let's add our server cert. Boom, edit and continue. Let's step out. Now, let's go execute this one more time. F10, F10, and I can see that I just took off about 550 milliseconds from the execution time of this method by using perf tips and being able to really quickly measure the performance of my application under the debugger in Visual Studio. Now, if I want the history of what I had done and I want other performance data as well, we have this diagnostics tool window that I had unpinned there. I'm going to pin it and stick it over here now, and I can see a history of all of the steps that were recorded and how long that they took. So if I'm interested as I'm stepping through and seeing a history of that, that information is available to me. I can see the CPU utilization of my process while I'm running it and testing it, and I can see the memory of my process while I'm running it. So let's go ahead and run a couple more tests while we're here. Let's keep clicking Get Apps. And as I'm clicking, every time I click this, notice I get a little uptick on my graph over here. So let's go ahead and click it about 10 more times. And I seem to have a problem with my memory. So I'm going to go to the Memory Usage tab, and I'm going to say Take Snapshot. So we've now brought memory tooling directly into the debugger. No more running other tools. And so I have a snapshot. I can go look at all the object types that are in there. But I'm not, maybe say I want to make sure as I run a couple things. So I'm going to run a couple more tests here. And as I keep doing this, I'm going to take another snapshot. And I can see that I've increased by about 50 megabytes while I was doing that. And if I click on this, it's going to bring me into a differentiated view. So I have diffs as well. And I can see that I've added 8 of these app container objects just in the time that I click those buttons. So looks like I'm leaking this app info container. I also have available to me the total size diff. So this is the size of the object itself. Inclusive size, this is the size of the object and all its children. So down here at the bottom, I have this reference types. If I choose that, that's showing me what app container is holding alive. So app container is holding a live byte array and an app info list of app info objects. And so I think this is probably my problem. So if I look at the paths to root, this is showing me what's preventing these from being garbage collected. So I'm creating a new one every time I click that button, but I don't expect them to hang around after the fact. And so it looks like what I've done is, for some reason, there's a selection changed event handler on the combo box. So these particular containers, when they're being created, they're registering with the combo box to be notified whenever the selection changes. But that has the side effect now that until I go clean up that reference, that it's going to continue to leak. Event handlers are a really, really common cause of the leak. So let's go find the selection changed event handler in my code. So let's go selection changed. Let's figure out where it helps if I spell it right. There we go. So I'm not really sure why anybody was registering for this. I'm sure somebody intended some functionality, but the application doesn't take advantage of it at this point, so we can punt on that particular problem. When I start debugging, the tool windows are up there, and as I click the Get Apps, I can see that no matter how many times I click it, I can get a spike, but then it looked like it came back down. Let's double check to make sure we really fixed it. Let's really measure it because we have tools. And when I click this, when I come in here, I don't see those in there, but I can search this view, and I can say app info. And it doesn't look like I had any app info containers in memory. So I can validate really quickly that I fixed my memory leak that way. So it's a brief review of the stuff that we just talked about. Any questions on that? Question right there.
When you look at how many milliseconds it took to execute a particular method, that should be independent on how long you spend in debugging, right?
Yeah, so the question was, when you look at how the time that we showed, the little perf tip, that should not include any time spent in debug mode? Absolutely correct. So we subtract all time that we know about that the debugger imposes. So we're not counting at all when you're stopped. So you could be stopped for 20 minutes while you go get coffee. Come back. If you press F10 and it's a int I equals 0, you're going to see it's going to say less than 1 millisecond. We also, if you step over a line of code and for some reason a module gets loaded and the debugger has to go look up symbols and the process is stopped in that time, we're going to subtract the time that we're loading symbols as well. So the number is a good approximation. And actually, it may show you a smaller number than it actually felt like it took you to execute it if you have certain events like that occur. On Windows 10 in .NET 4.6, which .NET 4.6 installs with Visual Studio 2015, we've actually even added extra instrumentation into the runtime and the operating system to help us get that number even more accurate. So, and that works for managed and native code, if anybody here does C++ development as well. One more question on this? The question was, does it work with asynchronous model as well? Yes, absolutely. They're on, and we'll look at some async code here in a minute. But how it works is it just, when you're stopped in the debugger at point A, when you start to run again, so whether via a step or whether a F5 to continue to the breakpoint, we start a timer, basically a stopwatch, and then when you stop again, either hitting the breakpoint or completing the step, we stop. So it's really just how long your code was executing between the 2 times that you were stopped in the debugger. And that's why when the first time you break in the debugger, so if you hit a breakpoint, like when you first launch your application, you won't see that number because we have to actually have a previous stop event. So the question is, can you store that into a file? Not yet. We are working on that ability. So it should be coming, if not by RTM. I hope that it would be there by RTM, but worst case scenario, it would be in the update following RTM. So, all right, let's go. We got a few more demos to get through, and our time is running short. So let's keep going. All right, so I mentioned that I had an application here that was going to talk to a server. We can go ahead and unpin the diagnostics tools now. And we do the get apps. It goes and gets my apps correctly. And I'm going to try to load mobile. Everything looks like it works correctly. However, if I do desktop, I have a problem. So I need to figure out what's going on. And for some reason, because using libraries doesn't work well for demos when there's no bugs in them, I've decided to implement my own security stack to encrypt the data going between the server and the client. And so I'm going to go ahead into this app data provider where I'm dealing with that information. And I'm going to set a breakpoint for myself. And let's see what we're getting in the case of the desktop. So let's go ahead and click Get Apps. Let's go ahead and load for desktop. And when I stop, I can see that for some reason, desktop is losing the P as part of it. So it makes sense that there's no applications being found of type desk-to. So I need to figure out what's going on. And to do that, I'm going to have to drop down into my string encoding library where I'm going to be applying a byte shift to those things. So we're going to use a breakpoint for this because I'm iterating on a lot of things in that particular string. So I'm going to right-click or set a breakpoint. And I can right-click. I can go straight to the conditions or actions. I'm going to jump to the actions. And in Visual Studio, we call this a trace point. Has anybody here ever used a trace point or the when hit functionality in the debugger? Okay, those of you who didn't raise your hand, you will love this for iterative things, I promise. What this does, this allows me to print a message in the debugger and automatically continue execution. So then I can go look in the output window, and I can figure out what was going on without having to stop and inspect stuff manually every time. So in this particular case, I want to, and this is modal again, or not modal, this is a peek window, so I can even look, I can copy code. So there's 3 types of things that I can type. I can type plain text. In this case, I'm going to say changing, and then I'm going to do inside of curly braces. This is going to allow me to evaluate variables just like I could in the debugger display attribute. Byte to mask, 2, and let's print the value of masked. And then there's a third type of thing I can do. If I type a $, this is a pseudo variable, just like you had the $, for the make object ID functionality. In this particular context, I can ask the debugger to print some information. I can ask it to print the address, the caller, the call stack, the function, process ID, process name, thread ID, or thread name. In this particular case, let's go ahead and just do the current function that we are in. And so when I do that, it saves. I can go down here. So I'm going to look at what I'm doing the conversion to. This is the encryption. And then I want to go look at what I'm converting it back to. This is the unencryption. And so in this particular case, let's go ahead and say I don't need the extra text here. So I'm going to say decoding. And let's go ahead and say byte to unmask, IntelliSense as I would expect. And that's being converted back to unmasked. So now, when I go ahead and start debugging, the other thing is, notice it became a diamond here. So the diamond is as the result of this particular checkbox. It says continue execution. If for some reason I wanted to print the message to the output window and also stop, I can uncheck the continue execution. You'll see it comes back to a circle. In this case, I want to go ahead and let it run. So I leave that checked. It's checked by default. It's a diamond. Diamond means it's not going to break, but it's going to continue executing. So when I start debugging this, I'm going to click Get Apps. I'm going to go ahead and click Desktop, Load. And now, it helps if I don't leave that set. When I go look in my output window, I can see the message that I just printed. Let me bring it up here to the editor so you can see this as well. So I can see that I converted what I converted it to, the value of that, and then I can see the function that I was in because I used the $sign. And it looks like my issue here is that for some reason it's converting 112 to 38, but then when it gets to the server side, it's being interpreted as 37, and it's now getting converted back to 111. So if I go look at my ASCII table, because this is an ASCII string, I'm going to figure out that my problem is that character 38 is an ampersand, which is a special character when I'm dealing with web stuff. So I'm going to go ahead and fix this in the debugger. And I want to go ahead and do that quickly. So let's go ahead and load by type. So let me go in here. Let me hit my breakpoint again. Let's say get apps, or load. And so now what I want to do is I want to go ahead and instead of dealing with this in a particular case of figuring out how to fix it in code, I'm going to look at the string encoder, and I'm just going to change the value in memory. Do you know that you can edit variables under the debugger? So I can go ahead and edit that, base 64 like that. It hasn't been fixed in my application, but again, for testing purposes, much like set next statement, I can force the debugger to see what's going to happen if I try other behaviors. And now I can see that changing to base 64 encoding versus ASCII encoding has fixed my bug for me. So editing variable values in the debugger is also something that can be incredibly helpful. So, all right, let's move on and say what's going to happen now in the case I have asynchronous code. So there's a question that came up about asynchronous code before. And I'm going to click this button, and I'm going to try to call an invalid URL, and I'm going to have a problem. Now, in my application, what I want to do is I want to go figure out where the problem's actually occurring. When I first graduated from college, I mentioned I wrote line of business applications. I used to go comment out try catches in my code because I didn't know how to make the debugger do what I wanted it to do. In Visual Studio, we have an exception settings window. We've also moved it under the debug windows now in 2015 RC. And instead of waiting for 6 seconds for it to come up, it's a fast new window for anybody that's used it before. Yeah, so it comes up instantly. It has really good search, so I can do null reference, for example. It'll find them really fast. So in this case, I'm going to ask the debugger to break on all common language runtime exceptions. That's the runtime for .NET. And so now, when I click this particular button, instead of stopping there, it's going to stop me where the exception's actually being thrown, even though it's not causing my application to crash, and it's being handled. So I'm inside this asynchronous method that I mentioned before. So I also want to point out on the call stack window, we have a feature called async call stacks. So if you've ever been debugging asynchronous code, how many people here write asynchronous code? Okay, fair number of people. So we shipped it in Visual Studio 2012. One of the things we found out, it's hard to debug because you don't know how you got to where you are, right? When you hit it, your actual physical call stack of the thread that you're on is really just this particular function. So this is running inside of a task. So the get is the top of the call stack logically. So what we added in Visual Studio 2013 is this concept of an asynchronous call stack. And to get a nice clean view, I'm going to switch to another view that I can in the debugger. Or I can do this anytime in the IDE. It's called full screen, and it's a different layout. So it'll remember, much like between debug and design mode, full screen versus another mode is going to remember what it's doing. And I'm going to go ahead and add the call stack window in here. And so I'm going to point out the few things that I have in the call stack window. I have the asynchronous that I mentioned. So anything inside a square bracket is what we call a pseudo frame. It's not real actual execution code. But we're going to tell you the logical stack that you clicked this. I clicked get bad URL.click. That made an asynchronous call to get apps from web async. That made an asynchronous call to this web utilities.get. So this is the logical call stack for how you got to where you are. That's a great feature when you're dealing with that. I also want to point out this external code. I mentioned just my code in the context of stepping into the application before. If I want to see what just my code is hiding from me, all the framework code, I can right-click on the call stack and say show external code. And this is what my call stack looks like now. So that is why we have just my code on by default. I'm now going to go ahead and hide that. The other thing that's worth mentioning is if you're interested, you can choose to configure or customize the way that your call stack appears to you. So we have a bunch of options, module names. Say I don't care about module names. I would actually like to know my parameter values. So I can turn that on, and now I can actually see the value of the string URL in the call stack window while I'm debugging. So that's a feature that's available to you. The only thing to note on that is that will result in display in the call stack window being a little bit slower, because just like in the watch window, the debugger has to go evaluate the values of all of those all the way up the call stack. So if it's a deep call stack, that could impact your stepping performance a little bit. And then I mentioned full screen mode is its own layout, so when I click full screen again, it's going to go back, it's going to jump, and I'm back into regular debugging mode. If I come back into full screen mode, it'll remember I laid that out. So that's another way that you can choose to get extra customization. So you might have I'm doing, task X, I'm going to use the regular debug view for that. I'm doing task Y, I'm going to come back and I'm going to use the full screen mode for that. Any questions? Right there.
What if you're having multiple threads calling the same code with the debugger, break symbol there, and it just keeps hitting it?
So the question is, what if you have multiple threads calling the debugger and it keeps hitting it? I'm glad you asked that question because that's going to be our next demo. So I'll answer that in 1 minute. As a brief review of what we talked about. Any questions on what we just talked about? One here. The question was, do the options that you just showed go to the stack trace in the trace point? I don't remember off the top of my head. I'm sorry. We can look at it really quick if you come up and talk to me afterwards. Sorry. All right. So for the sake of time, I'm going to go ahead and move on to our last demo of the day, which thank you to the gentleman that asked about multi-threading, since come see me afterwards, and I'll give you a prize. So I have a function here in our WPF application that we're dealing with. It's going to calculate some prime numbers in parallel. So what it's doing is up here in my button click, I'm generating an array of numbers from 0 to whatever value I passed in. Thanks to our call stack window, we can know what number I passed in, 5. And I want to know which values are, I'm going to calculate which numbers are prime. I'm going to generate a list of the numbers that are prime. And I want to do that in parallel because calculating prime numbers can be expensive. So how do I know how many threads I actually have executing right now? Does anybody know? I'm going to use a new window called, not new window, it's been there since Visual Studio 2010, but if you've never seen it, it's worth seeing. It's called the Parallel Stacks window. And this is going to show me a view of all of my threads and how they're executing. So I can see that I have 8 total threads in my process. I have 3 threads that are in this number utilities.isPrime via this particular code path here. And I can see that I have 1 thread that is in isPrime as well that's in a different code path. So it turns out that when you use the framework to automatically parallelize things, which I've done by using as array.asParallel, it's going to decide how it schedules those tasks. So one of the tasks was probably my main thread, so it just let it go into that, and then it spun up some anonymous threads as well. So I want to deal with some specific threads. So one of the questions was, what do you do in the case of a breakpoint? I mentioned the debugger location toolbar, and I mentioned the filter breakpoint earlier. So if I set a filter breakpoint, I can do it based on the thread ID. Let's go ahead to, so actions. Sorry, let's go ahead and shrink this down to get a little bit more space here. I'm going to use a filter. And so now I can actually say thread ID equals 13652. So I don't want any other threads. This is going to tell the debugger to not actually stop any other threads on that particular breakpoint. Now, one of the ways that I could actually enforce that is if I want to test this. So I don't want this thread to run because I don't want this to be hit again, but I want to let all the other threads in the process run. I can do that from a couple different places. I'm going to show one more window, and that's going to be the threads window. And let's go ahead and just dock it. Yeah, that'll be good. Over there, we're going to unpin this for the moment. And so in my threads window, I can see all of the threads that are executing, and this little yellow instruction pointer shows me my current thread. So I'm going to right-click on this, and I'm going to choose to freeze that thread. This is going to tell the debugger not to let that thread run. And now I'm going to click Continue, and I'm going to let all the other threads in the process run. And you can see that breakpoint's not being hit by any other thing. So I'm going to asynchronously break now. We're going to resume execution of that thread. So it's getting in the way of. We're going to unfreeze the thread, which is called thaw. And now when I click Continue, you'll see that breakpoint will be hit. So filter breakpoint's a good way to do that. Another tip in the context of multi-threading debugging is once you've hit a breakpoint will be hit on any thread. But once you unset that breakpoint, if you start stepping, we will only ever finish a step on the same thread that we started a step from. So if I F10, if you look up in the debug location toolbar, you're going to see that the thread ID is not changing because I only have stepped from a single thread. So stepping is another thing that you can do. Hit a breakpoint, unset it, and then if you don't want to deal with setting up the filter, you can go ahead and you can just start stepping on that. The last two tricks I wanted to show in terms of multi-threaded is we have a feature called Show Threads in Source that when I click is going to show me where all of my threads are. Now, since I let all the other threads run for a while, I'm sure they're completed, so I'm going to go ahead and continue this. We'll come back in with another breakpoint. And so as I do this, let's go ahead and run to this particular location again. You will start seeing, as you hover over them, multi-threaded demos are a little quirky, but let's unset you. I can see where all of the threads are in the process, so they happen to all be on this particular line of code. But if they were distributed somewhere else, so let's see what happens when I do this and race again. I can now see that I have some threads on this line of code. I have other threads up on this line of code. So last piece of interesting functionality for our talk, your last demo in the context of multi-threading is several of our windows will give us this functionality, but I can choose to flag threads. So I could, for example, say one thread is here and 6 threads are here. Let's say flag. I can flag all of these particular threads. Let's say I want to get them all to here. I can right-click. I can say Run Flagged Threads to Cursor. Let's go ahead and freeze this thread so it's not going to execute at all. And then let's go ahead and run our flagged threads to the cursor. And so now, it helps if I don't set a breakpoint, but I can see that I can control which threads I do by choosing to flag those particular threads. All right. So there's a brief review of what we talked about, a really, really fast overview of multi-threaded debugging. Any questions on that? Take one really quick. All right, so I promised to tell you how to help us make Visual Studio better. So we like to do calls and studies with customers. So you can participate in these. Carl, are you in the room somewhere? Carl, so he's waving his hand in the back. If you go sign up with him, a lot of the stuff that we do, so the breakpoint stuff, the diagnostic tool window, the perf tips that you saw, that was all done in PowerPoint that we showed to customers. We can do it over Skype. And we say, hey, what do you think about this? Would this be useful to you? And we iterated on that for a long time, so you can participate in that. Go sign up with Carl in the back or email me. My email address is there. Let us know what works and doesn't work. Send a smile. It's integrated into Visual Studio. You can report bugs that way. If you hit something that doesn't work for you, don't assume that somebody else has hit it. Please report it to us. All the time I get emails internally, people that work at Microsoft, and they're like, I'm assuming this is known, but I'm having this particular problem. And most of the time we say, no, it's not known. So if you report it to us, we're happy to fix it. I promise somebody reads every single send a frown that you send us, every bug report. And if you include your email address, we will follow up with you on that. We have an opportunity to participate in a focus group at Ignite. So Carl is going to wave his hand again. We were interested in talking to people that do mobile development and cloud development. Sign up with Carl. We'd love to just sit down with you for about an hour and talk to you about the types of problems that you have to debug, that you hit out in the wild, that you wish you had better tools for. This could be on the Microsoft stack. It can be Android. It can be iOS. It can be Amazon Web Services. We're just generally interested in mobile and cloud development, the general types of problems that you have. I promised some resources. There's an IntelliTrace talk on Friday. There's a talk we did deep diving on the performance tool window at Build. I've included a link if you're interested in going and watching that. And everything new that we do, we announce on our team blog. So there's a link to that if you want to go download the slides. So thank you very much.